It's happening. The Ring of Fire is awakening. This ring of volcanoes has been quiet for a very long time. But according to new data, there is increasing tectonic activity in this area. And as we know, where there is tectonic activity, there are earthquakes. So if you live along the Ring of Fire, you better prepare yourself because big earthquakes are coming. I will tell you everything about the Ring of Fire and what scientists have just discovered in this area. But before we go to the video, click on the subscribe button so you won't miss any new videos. So, the Ring of Fire, also known as the Circum-Pacific Belt, is a major belt of volcanoes and earthquake zones that stretches around the Pacific Ocean. It is almost a continuous band about 40,000 kilometers long that encompasses the basin of the Pacific Ocean and includes about 75% of all volcanoes on the planet and 90% of earthquakes. In other words, the Ring of Fire is home to some of the world's most active volcanoes and earthquake-prone areas. As you can see, the United States, Japan, the Philippines, Indonesia, New Zealand, and many other countries are located along the Ring of Fire, which makes them vulnerable to volcanic eruptions and earthquakes. And even though the Ring of Fire is not actually a ring but a horseshoe shape, I will refer to it as a ring for simplicity's sake. The reason why the Ring of Fire is so active is due to the fact that three of the Earth's tectonic plates meet here: the Pacific Plate, the North American Plate, and the Eurasian Plate. The Pacific Plate is moving towards the other two plates and getting destroyed by them, which causes a lot of friction and stress to build up. This stress is released through earthquakes and volcanic activity. But there are four areas within the Ring of Fire that are particularly active. The first is the Basin and Range Province in the western United States. This area includes the Great Rift Valley and the San Andreas Fault, and is prone to both earthquakes and volcanic activity. California is one of the most seismically active regions in the world because it is situated on the southern part of the San Andreas Fault line, which runs for about 1,300 kilometers through the state. The majority of California's earthquakes occur along this fault line, which separates the North American Plate from the Pacific Plate. The second is the Mariana Islands, Micronesia, and eastern Australia. This area includes the Mariana Trench and is prone to earthquakes and volcanic activity. The Mariana Islands are located on the western edge of the Pacific Plate and the eastern edge of the Philippine Sea Plate, which is subducting beneath the Pacific Plate. This subduction zone is responsible for the high level of seismic activity in the region. The third is the Eurasian Islands Arc System. This area includes the Eurasian Plate, the Philippine Plate, the Sunda Plate, and the Pacific Plate. This area is prone to earthquakes and volcanic activity. For example, Indonesia sits on the Ring of Fire and is prone to earthquakes and volcanic eruptions. In 2004, a 9.1 magnitude earthquake struck off the coast of Sumatra Island, Indonesia, triggering a devastating tsunami that killed over 227,000 people in 14 countries. And the fourth is New Zealand and the southwestern Pacific Ocean. This area includes the Pacific Plate and the Australian Plate. New Zealand is prone to earthquakes and volcanic activity. In 2011, a 6.3 magnitude earthquake struck Christchurch, New Zealand, killing 2 people and causing billions of dollars in damage. For many years, the Ring of Fire has been relatively quiet. However, now the situation is changing. According to recent reports, scientists have recorded an increase in tectonic activity in the area. This could be the beginning of a new volcanic or earthquake cycle. One of the reasons for the increased activity could be related to the movement of the Pacific Plate. This plate is continuously moving and colliding with other plates, such as the North American Plate and the Eurasian Plate. As a result, stress is built up along the plate boundaries and is released through earthquakes and volcanic activity. It is possible that the stress levels have reached a threshold and are now being released, leading to the observed increase in activity. Another factor that could contribute to the increased activity is the release of fluids from the Earth's mantle. As the Pacific Plate subducts into the mantle, fluids are released, which can reduce the strength of the rocks around them. This can lead to more earthquakes and volcanic activity along the plate boundary. Here is an interesting fact. In April 2016, a magnitude 7.8 earthquake struck off the coast of Ecuador, which is not typically a seismically active region. The earthquake was unusual as it occurred in a region that had not experienced significant seismic activity for a long time. It was surprising because Ecuador is not located in an area that is known for frequent earthquakes. In fact, the country's seismic history was thought to be relatively benign prior to the 2016 event. Another interesting fact is that the largest earthquake ever recorded occurred in Valdivia, Chile in 1960. This earthquake had a magnitude of 9.5 and was caused by an undersea earthquake that triggered a tsunami and affected areas as far away as Japan, the Philippines, and Hawaii. The earthquake resulted in significant loss of life and property and is considered one of the deadliest natural disasters in history. Well, we talked about the past, but what about the future? What can we expect in terms of earthquakes and volcanic activity along the Ring of Fire? Predicting earthquakes and volcanic eruptions is very difficult as these events are complex and influenced by various factors. However, based on historical data and scientific analysis, some areas along the Ring of Fire are considered to be at a higher risk of seismic activity in the near future. For example, the United States Geological Survey, USGS, monitors earthquake activity around the world and provides probabilistic seismic hazard maps for different regions. According to their maps, areas such as California and Alaska are at a high risk of strong ground motions in the next 50 years. Similarly, the New Zealand GeoNet, which is a national network for monitoring earthquakes and other geological hazards, has identified areas such as the Upper North Island of New Zealand as being at a high risk of earthquakes in the next 25 years. It is important to note that these are just estimates based on historical data, and actual earthquake activity may vary. Also, predicting volcanic eruptions is even more challenging as it involves monitoring various indicators such as seismic activity, gas emissions, and ground deformation. However, volcanic eruption forecasts are typically issued by local authorities or geological surveys when there is an elevated risk of an eruption. Overall, while it is impossible to predict exactly when and where earthquakes and volcanic eruptions will occur along the Ring of Fire, scientific monitoring and analysis can help identify areas that are at a higher risk and allow for better preparedness and mitigation measures. In conclusion, the Ring of Fire is a major belt of volcanoes and earthquake zones that stretches around the Pacific Ocean and includes about 75% of all volcanoes on the planet and 90% of earthquakes. The increased tectonic activity along the Ring of Fire could be the beginning of a new volcanic or earthquake cycle due to the movement of the Pacific Plate and the release of fluids from the Earth's mantle. Areas such as California, Alaska, the Mariana Islands, Indonesia, and New Zealand are at a high risk of seismic activity in the near future. While predicting earthquakes and volcanic eruptions is challenging, scientific monitoring and analysis can help identify areas at a higher risk, allowing for better preparedness and mitigation measures. So if you live in one of the countries along the Ring of Fire, it is important to stay informed and prepared for potential seismic events. Thank you for watching and subscribing. See you next time.